In this lecture, we'll look at more JavaScript object concepts, including constructor and constructor properties, the global object, even a bit of recursion. We'll be using a revised version of the linked list from the last lecture to illustrate these new concepts. Let's start by looking at how we've changed init linked list on lines 1 through 16. First, the name is now linked list, almost as though it were the linked list class, even though it's still just an initialization function. JS has no classes, but object initialization functions, like linked list, which we'll call constructors from here on, following JS terminology. Such things constructors are pretty close to a class declaration in a certain sense. Think about it. In a traditional OO language, the class determines what member data an object will have and what methods. A traditional constructor merely sets initial values for the member data that was determined by the class declaration. But a JS constructor does both. When the object goes into the constructor, it's empty. When it comes out, it has data properties, function properties, and the data is initialized. So the JS constructor is like the traditional class declaration and traditional constructor all rolled into one. So in JS, constructors take the place of classes, loosely speaking. And to make them look even more like traditional classes, JavaScript includes a new operator, which you use as shown in the transcript here. You could, for instance, declare a variable x and assign it equal to new linked list with parentheses after it. Now, that sure looks like a Java-style object creation and construction, and it's deliberately designed to look that way, in what some JS developers think is sort of pandering to old coding models, in fact. Despite its looks, this statement does not make linked list a class. It's still a constructor function. The statement creates an empty object, passes it to linked list for setup, and makes x point to it. But linked list has no parameters now, right? You can see it up here. So how is this empty object passed? As the this value. All JS functions have a this, not just ones that are function properties of some object. For global functions, like linked list here, the this parameter points typically to the global object, which we'll discuss in a moment. But when you invoke a function via new, like we do in the transcript and also down here when we're setting up our array of linked lists in our main, when you do that, then this points to a new empty object to be initialized. As you can see, we've replaced all instances of list with this all the ones that were in the old init linked list have been replaced with this in the new linked list. Such a use really is consistent with the idea that this provides the context object, right? Because in a traditional constructor, the context object is the object being initialized. And so it is in a JS constructor. Since any function has a this, any function can be used as a constructor. But most functions have other purposes and don't attempt to initialize their context objects from scratch. Whether a function is a constructor or not is entirely a matter of usage. By convention, any function that works as a constructor is capitalized, both to avoid accidental misuse and to reinforce the idea that a constructor in JS takes the place of a class in traditional languages. And a final note, by the way, a constructor may have additional parameters. Aside from the hidden this, you just add them to the header and pass them in the parentheses in the obvious way as shown here in the transcript. New size to linked list, perhaps, and pass it an initial size, for example. So let's talk a little bit about the global object. What is that? Well, up till now, we've said that any variables you declare outside of a function are global. But that's a simplification. In fact, every JS setup has one overarching global object of which all globally declared variables are a property. This global object is the only data in a JS program that's not local or a property of some other object. In some JS configurations, it has a name. It's called window in browser embedded JS, for instance. Sometimes, as in textual JavaScript shells, it's nameless. But it can always be reached via this if this is not otherwise in use. As we said a moment ago, every function has a this, and it defaults to the global object. We also said in a prior lecture that JavaScript functions were a special form of object. A JS function is merely a standard object with the added property of some code, plus, by the way, a closure context, as we'll see later, but we won't talk about that just yet. This means that JS functions may also have data and function properties of their own, just like any other object. Lines like list.add, which is a function, of course, .counter equals 42, are perfectly legal and sometimes useful. There are often data or methods that relate to an entire family of objects that were created by a common constructor. JS doesn't have classes, but all objects initialized by, for instance, linked list here, might consider themselves to be a sort of club, and the club might want joint property that's held in common by all objects in the club, all objects that were created by linked list. In a traditional language, you do this by declaring static data, or static methods. In JavaScript, you do it by attaching properties to the constructor, since the constructor is JavaScript's ersatz class. For instance, on lines 18 through 25, we declare a function toDrop that performs a recursive removal of a node from a list. Get to that in a little bit. The function is partly there to illustrate recursion, but it also shows how a function may be attached to the constructor as a property. toDrop doesn't use this, and it doesn't really belong to any list object. It's just passed a head pointer to some list and a value to delete. It's meant for use by any list object as a utility to help in drop, which you can see it's called from on line 14 here. When you have such a function, or data, a general constant perhaps, that is not suitable as a property of the objects themselves, but is still needed by all objects created by the constructor, it's good style to attach it to the constructor. You can see this clearly in the documents and design of the wrapper objects for string, number, and boolean. And these are created by the constructors, capital string, capital number, capital boolean. Some utility methods are members of the actual wrapper objects, like trim, for instance, or toUpperCase. And they have to be called on a particular string. String1.trim or string2.toUpperCase, for instance. But others are members of the constructor for the wrapper and are called without a string object. String.fromCharecode, which we saw in an earlier example, for instance. And there we have sort of a summary of those two things up on the diagram. Now, here's a question one for you. Is it just a matter of taste to attach fromCharecode to string instead of making it a property of the string objects themselves? Or does it make inherent sense to make fromCharecode a property of string, while ChareCodeAt, for instance, is a property of the string object? Why or why not? What is the reason for those decisions? Coming back from a pause, if you think about it, it makes inherent sense. If you're calling fromCharecode, it's because you want to create a string object from a character code. You don't have a string object already. So the function can't be a member of a string object, and it doesn't need to because it doesn't use any existing string object for data. But if you call ChareCodeAt, you're getting information from an existing string object, and the function needs to be associated with a particular string object via a this pointer, of course, in order to get the data from which to derive the character code. So here's question 2. Do you think the code for string.fromCharecode would use this? If it did, to what would this refer? And coming back from a pause there, it wouldn't use this for the reasons stated under answer 1. It doesn't belong to any string object. Its this pointer would refer to the global object, in fact. Okay, let's do a brief digression here and talk a little bit about recursive functions. They're not strictly an object-oriented concept, but we need to mention them somewhere, and a recursive list drop implementation seemed a good place to do so. So the doDrop function calls itself on lines 21 and 23, as you can see here. It is also the first function in our examples to have a name between function and the opening parentheses right there. Not all function declarations have to be anonymous. Functions may have names, but sophisticated JS design only uses a direct function name in special cases, such as recursion, where a function benefits from being able to name itself or call itself. This is not a course on recursion, but a brief overview of how toDrop works is probably in order. If head is null, then the list in question is empty. No delete is possible, and we return the existing head value. If there's a first node, then if its data matches val, we want to delete it. So we return the result of doDrop on the remainder of the list, recursively calling, and omit the first node entirely. If the first node's data doesn't match, then we keep the first node, but we point its next pointer to a possibly reduced list resulting from doing a doDrop on the rest of the list, again recursively, removing any val matching nodes further down the list. Now trace that a bit to be sure you understand it, and then a quick question. What does doDrop do if all the nodes have val matching data? Coming back from a pause, it'll remove all the nodes. Each call in turn will invoke line 21 until the final one returns null, which will be returned by each in waiting call all the way back to the top level, and we'll end up with head as null. Now, the print function from the earlier example has been replaced on lines 8 through 11 here by a apply function. Apply, as you can see, loops through all the nodes, like print did. But instead of printing their data, it calls the function that was passed by a parameter action on each data item. This is much more powerful, since it allows the caller to pass a function that does anything they want to each datum. On line 37, down here, we implement the print command by calling apply with an anonymous function, passing it an anonymous function that prints whatever is passed to it, enclosing the print in parentheses. Let's run the code, and you can see that it will work just fine, and that we've been able to control the formatting, adding those parentheses from the caller. So we'll fire up a little JSDB session on the file, and let's add hello to list 1 and goodbye as well, and then we'll print 1. And there we go. Now, this pattern of supplying an anonymous function that specifies a general action to be done, and perhaps passing that to another function, is very common in JS and other scripting languages. It's the sort of thing that might be done in Java by an interface-derived class, like perhaps comparator, but it's done in JS by simply creating an anonymous function as a callback to be used by another function. As you get into JS, you'll find that anonymous functions get thrown around a lot to describe little bits of functionality, and again for those closures that we keep alluding to. Indeed, we've applied this anonymous function idea to our main driver. We no longer have a variable LL driver. Parse carefully through lines 28 through, really 28 and 41, the middle part isn't the essential issue, and you'll see that what we have now is of the form anonymous function in parentheses and a call of that anonymous function declaration. Thus, the anonymous function, of course, extends from that parenthesis to there, and then there's the call right afterward. So we have a parenthesized anonymous function creation followed by a call operation which runs the anonymous function. The anonymous function itself has to be parenthesized, by the way, due to subtle issues in JavaScript precedence. So it's one of those just do it things. When you only use a function once, this is a more elegant way to create and run it. No need for an extra global variable in a separate function call. And importantly, this is not some clever illustration of odd syntax. Creating an anonymous function and calling it just once is a very common pattern in closure-based JS code, as we'll see. A modern sophisticated JS program will have hundreds of instances of just this pattern, so it's good to get used to it. And indeed, we'll shortly have an LMQ that relies on this pattern. You may have noticed, by the way, that I also dropped the count command in its data. That's just to reduce clutter in the example. No other point than that.